Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 paper 2. In today's lesson, we will start from question number 15 and we will try to cover all remaining questions in today's lesson. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 15 says, a teacher demonstrated the behavior of electrons traveling through graphite. An electron beam was directed through a thin piece of graphite towards a fluorescent screen as shown in the figure. The electrons produced a pattern on the fluorescent screen as shown below. For part A, this demonstration can be used to make the conclusion about the behavior of the electrons and structure of the graphite. State these conclusions. Means question is asking you, in your answer, you have to talk about behavior of the electrons and structure of the graphite. So it's very important, read question carefully and try to understand what is question and then start writing your answer. Not just read and start writing whatever is in your head. You need to understand what is question. And so in the answer we have to talk about behavior of the electrons and structure of the graphite. So what kind of behavior we see from this one? So imagine that first of all, if electrons are particles, so when they pass through graphite we will just see them at one point. We will see them means we can expect we will see them at one point. All of them, they will go straight through the graphite because we are using in this case thin beam of electrons, mean electron beam is used, mean electrons are just traveling in a straight line, so we will expect them to see them at one point. But what we have seen, what we have observed, we observe circles, and this is telling us there is diffraction. So this tells us diffraction means in this case electrons they spread out, and spreading out is diffraction, and diffraction is only property of waves. So this is only property of waves, mean waves can exhibit this kind of behavior. So from here we can say in this case electrons are behaving as wave. How do we know they are behaving as wave? Because electrons diffract. So there is a diffraction of electrons, and diffraction takes place if gap size is about equal to the wavelength of the wave is about equal to lambda of the wave. So in this case lambda for electron, it has a special name, we call that is de Broglie wavelength, or simply we can say that is de Broglie. Actually proper name is de Broglie. So this d we can write down small letters, so this is de Broglie. So the proper way of reading this one is de Broglie wavelength. So this is de Broglie wavelength. So these are the points you need to simply understand. So when we look at the pattern, so it means electrons are behaving like a wave, and this is diffraction pattern, and diffraction is property of waves only. And diffraction takes place when the gap size is almost equal to the wavelength of the wave, means significant diffraction takes place that time. So this gap size means that this is gap between atoms, or we can say spacing between atoms, and we see these kind of regular circles. It means atoms inside crystal, they are arranged in graphite, they are arranged in an order, means they have regular pattern. So these things you need to understand. Physics is not about memorizing. Physics explains the beauty of nature. So you need to understand physics, not just memorize. I hope these points are clear to you. Now let me show you the answer, how you can write down your final answer. So this is what you need to write down. For the answer of this question, we need to talk about the behavior of the electrons and structure of the graphite. So we can say electrons diffract as they pass through the graphite. So this is graphite, pass through the graphite. So electrons exhibit wave behavior. So we can see this pattern is a diffraction pattern. It means electrons diffract, so they are showing wave properties. It also shows that structure of graphite must be ordered because they are regular. These circles, concentric circles, they show regular pattern. As there is significant diffraction, so deep wavelength of electrons is similar to spacing of gaps between graphite atoms. So this is how step by step you can answer. So you need to develop your understanding when you look at the question, how to approach step by step. Part B says the electrons were accelerated through a potential difference of 2400 volts before interacting with the graphite. Show that the work done on each electron is about 4 times 10 to minus 16 joules. So if you look at this figure, so here first of all we will produce electrons, means electrons will be emitted, and then potential difference is between cathode and this anode, means positively charged plate. Electrons will accelerate and they will gain kinetic energy, and here work will be done by electric field. And so how we can calculate that work done? So simply first of all you can imagine, for better understanding, we can imagine we have one negative plate and this one is one positive plate, and potential difference between these two plates is 2400 volts. We can also imagine if one electron is here, electron will have electrical potential energy, and when electron will reach this plate, that energy will be converted into kinetic energy. But the better way to write this one is, we can say the change in EPE will be equal to change in KE, because electron when is moving from negative to positive, electron is losing electrical potential energy and electron is gaining kinetic energy. So in this case simply we can say work done will be equal to change in EPE, and change in EPE is equal to Q times delta V, and charge on single electron is equal to 1.6 times 10 to minus 19 coulombs, and potential difference we have between these two plates, that is 2400. And if we simply multiply this one, we will get our final answer, that will be equal to 3.84 times 10 to minus 16 joules, and this is very close to 4, means up to 2SF. We can say this is 4.0 times 10 to minus 16 joules. So this is our final answer, and this is how you can approach a beautiful way to answer this one. For the second part, we need to calculate the maximum velocity of the electrons. May you understand how to calculate this one, but maybe you are not clear why they are saying it is the maximum velocity. So let me explain you why they are saying this one is the maximum velocity. So we will go back to this capacitor setup again. So here we have positive plate and also we have negative plate. So as we discussed before, here we have potential difference between these two plates. So this one is the potential difference. They are saying the maximum velocity. As I mentioned before, at this point electron has EPE, electrical potential energy, and when electron reach at this point, it will have kinetic energy. So in this case we are assuming that all the EPE has been converted into KE. So in this case we can say speed of the electron will be maximum. So maximum speed means that the change in EPE in this case is equal to change in kinetic energy, and change in EPE we have already calculated, that was 3.84 times 10 to minus 16. We have already calculated. So here we have 1/2 mv max square, and V max we need to calculate. So we can say V max in this case will be equal to 2 times 3.84 times 10 to minus 16, and this has to be divided by m, the mass of electron, and we need to take square root of this. So here we have 2 times, this is 3.84 times 10 to minus 16 and divided by mass of electron, that is 9.11 times 10 to minus 31 kgs, and if we take square root of this one, our final answer will be equal to 2.90 times 10 to 7 meters per second. Very high speed. So this is how we can calculate, and this is the maximum velocity, maximum speed, because in this case we assume all the electrical energy has been converted into kinetic energy. Third part says the accelerating PD was then increased. Explain how the pattern on the screen would change. Mean how this pattern will change if we increase this PD. Means the potential difference between cathode and anode. If we change this, how pattern on the screen will change. In order to understand this one, we need to understand the relationship between wavelength and momentum of moving particle. This is de Broglie wavelength. So this is de Broglie wavelength. So this is de Broglie wavelength. For this question, it is given to us potential difference increase, but we have no information about momentum. So how we can link this momentum with PD? So first of all, we need to understand how kinetic energy is linked with momentum. Then we can link kinetic energy with PD. Kinetic energy is equal to 1/2 mv square. We can say this is 1/2 mv times v. Now if I multiply this one with m and divide by m, we can simply write down this is 1/2 mv. This is here we have 1 mv. These two we can combine. This is another mv and this is divided by m. And you need to understand is that mp, this is equal to momentum. So we can simply write down here this will be p square divided by 2m. So this is how kinetic energy is linked with momentum. From here we can say momentum will be equal to 2m ek, root of this one. But we have already discussed that kinetic energy, this is equal to q times delta v. So we can write down here this is 2m. So ek you can replace with q times delta v. So the root of this one. Now we understand how momentum is linked with PD. So we can simply write down here this is h divided by 2m q times delta v and root of this one. So if PD increase, it means lambda will decrease, and if lambda decrease, diameter of circles decreases. So let me write down one point here. If the lambda this go down, diameter of circles also decreases. So we will say diameter of circles also decreases, and if lambda increase, diameter of circles will increase. Mean diameter of these circles, in this case lambda is decreasing, so diameter of these circles will decrease. Mean these circles become smaller and they get closer, and spacing between circles also decreases. So these are the points you need to understand to answer this question. And if you are curious about lambda and how diameter decreases, you need to understand this equation, and this is not part of your syllabus, this is just for your informations. So if this lambda decrease, this is constant, d is the spacing between atoms, so sine of theta will go down. If sine of theta decreases, it means that theta also decreases. So if this theta decrease, it means diameter of this circle will decrease. I hope this is clear to you. Now let me show you the answer. In your answer you can mention these points, so I will just clean this. So we can clean this part. So this is how you can write down your answer. In your answer you have to mention these points. You can say increasing the accelerating PD increases the maximum momentum of the electron. So we have mentioned these points. Then you can use this formula. Then you can say as in this case momentum increases, it means lambda decreases. So wavelength of electron decreases, so diameter of the circles would decrease. So this is how you can answer. Question 16 says a solar cell has a thin coating of thickness d to reduce the reflection of light. White light incident on the coating is reflected from the top and bottom surfaces of the coating. This produces a final reflected beam as shown in the figure. For part A, explain why some wavelengths of the incident white light will be missing from the final reflected beam. So simply question is asking us why missing wavelengths. The reason behind that missing wavelengths due to destructive interference. So I hope you will simply say that will be due to destructive interference. And we also need to write down the condition for destructive interference, means why destructive interference will take place in this case, and that will be due to path difference. If this is equal to n plus 1 by 2 times lambda. So these are the two main points you have to mention in your answer. Now if you look at this figure, so I'm assuming this is rare medium because this is there, so this is rare medium, and coating, so this is dense medium, and I'm assuming this one is the denser medium, means denser than coating. So at this point, reflected beam, its phase will change by 180 degrees, and phase of wave at this boundary also will change by 180 degrees. So now if the thickness of the coating means 2d, if this is equal to lambda by 2, and this is the lambda in the coating, means the wavelength of light, it depends on the medium. So this lambda is in this coating. If this condition is true, it means there will be destructive interference. So it means that here if we have this, means this reflected beam, and the other one will be 180 degree out of phase, and here we will see no light because this is due to destructive interference. So these are the points we need to understand. If these points are clear to you, now let me show you the answer, how you can write down your answer. In your answer, you can talk about these points. Destructive interference occurs when the two reflective waves meet in antiphase and they cancel each other. This cancellation causes missing of wavelengths. Destructive interference will take place if PD between two waves is equal to this. So these 3 points if you write down, you will get 3 marks. I hope this makes sense to you, and in the second part even we will discuss more about this one. Part B says white light is incident perpendicular to the surface of the coating. Calculate the wavelength that would be missing from the final reflected beam. Assume the refractive index is 2.3 for all visible wavelengths, and value of D is given to us. In the last part we have already discussed that destructive interference will take place. Destructive interference will take place if 2d means the thickness of this coating, this is equal to lambda by 2. Thickness is d, means 2 times of the thickness, means the total distance traveled by the light in the coating. So this is equal to 2d. We are assuming angle is 90 degrees, so simply we are assuming light go this way and the waves then come back along this way. So it means the total distance in the coating is equal to 2d. So we can find out value of lambda in the coating. So we can say this is lambda coating. So this is lambda coating, and this is equal to 2 times value of d. So it means 4 times d, and value of d is 6.5 times 10 to minus 8 meters. So if we multiply this one, we can find out value of lambda. Lambda will be equal to 2.6 times 10 to minus 7 meters. But this is wavelength in coating. We need to find out wavelength in air. So for this purpose we need to understand refractive index of the medium, divided by refractive index of air or in vacuum. This is equal to speed in vacuum. So we can say this is speed in vacuum or speed in air divided by speed in medium. So speed, we can say this is f times lambda. So this is lambda in air, and this is f times lambda in medium, means in this case we are talking about coating. So from here we can cancel this frequency with this frequency. Now from here we can write down n medium means refractive index of coating divided by refractive index of air. This will be equal to lambda in air divided by lambda in coating, or medium is coating. So we can find out lambda in air. So lambda in air, this one will be equal to lambda of coating multiplied by n of coating. So this is n of coating. So this is the wavelength in coating. Now lambda in air is 1, so we no need to write on that. N in air is 1, means the refractive index of air is equal to 1. Now simply we need to multiply these two. So we have lambda in coating, this is 2.6 times 10 to minus 7 meters, and value of n is 2.3. One thing you need to understand, they have given you that refractive index for all wavelengths is equal to 2.3, but refractive index increases if the frequency increases. So it means that blue color has higher refractive index as compared with red color. So this point is also very important to keep in mind. Maybe they can ask you next time. Now simply we need to multiply. If we multiply these two, we will get 5.98 times 10 to minus 7. This is in meters, so in nanometers we can say this is 598 nanometers. Part C says a solar cell array is placed on the roof of a house as shown in the figure. The area of the solar cell is 8.7 square meters. The roof of the house slopes at an angle of 60 degrees to the horizontal as shown below. When the intensity of radiation from the sun perpendicular to the surface of Earth is 1.1 kilowatts per square meter, the output of the solar cell is 5.4 times 10 to 6 joules per hour. For this question we need to calculate efficiency. So efficiency, first of all, we can write down this will be equal to P out useful divided by P in. So this is the input power. So we have P out, so simply we can write down P out. This is equal to 5.4 times 10 to 6 joules per hour, means 60 times 60. So here we have joules. This is in seconds. So if we solve this one, we will get 1500 watts. So we can convert this one into kilowatts. So this is our P out. So simply we can plug in. Now we need to find out P in. So we can say incident power. So we can say incident power on solar cell, on solar array. So this is what we need to calculate now. For this question, it is given to us intensity of radiation from the sun perpendicular to the surface of Earth is 1.1 kilowatts per square meter. 1.1 kilowatts per square meter. So we have 1.1 kilowatts per square meter, means per 1 square meter here. And now simply we need to multiply with area of the solar array. Which area we have to consider? So it is given to us rays are incident perpendicular to the surface of the Earth like this. So which area we have to take in this case? We have to take the projected area, mean this area we have to take. This area, and this one is cosine of, so this side is cosine of theta. So if this area, let's say, is A, so this has to be A cosine of theta, and this value is given to us, that is 8.7. So it means we have to multiply with 8.7 cosine of 60 degrees. So this is meter square. Now if we solve this one, we will figure out incident power on solar array. So the incident power in this case will be equal to 4.785 kilowatts. So simply we can plug in values here now. So we have 1.5 kilowatts, and this is divided by 4.785 kilowatts. So this is kilowatts, this is also in kilowatts, and if we solve, we will get, this is our final answer. So this is about 31%. So this is our final answer. I hope this is clear to you. So you have to take area, this projected area, because it is given to us intensity of radiation from the sun perpendicular to the surface is 1.1. Perpendicular to the surface is given, so we have to take this area. So that's the main tricky part of this question. I hope this video was helpful. Please like and subscribe because your encouragement is very important. And remaining questions I'll be uploading by tomorrow, and all the questions will be uploaded before your exam.